This lesson is about how distributions of data commonly look. So this is still the unit on statistics, and we just want to see how do distributions tend to sort of certain ways they can be described. There's commonalities that we can get for them. All right. So we're going to look at some specific ones. We're going to look at a normal distribution. We're going to look at a skewed distribution. And it should just be sort of a quick run through, just so you have a good overview, a brief overview of what these different distributions look like. So in the first example, Alice recorded the heights of people who walked into a hockey arena over a 2-hour period. So she's standing at the door. She asks them to measure them. They oblige. She gets this list of data, and she puts it in a table. She put it into what's called a frequency table. Notice how on the left-hand column, class intervals of heights, what we got here is ranges. So we can't have every single individual height. We can't have one for someone who's 101 centimeter tall and another one who's 101.1 or whatever. So she groups them. And what you can see is she's grouped them in 10 centimeter intervals. So everybody who's between 100 centimeters and 110 centimeters goes into this first group. And then everybody who's between 110 and 120 goes into the next group. And then 120 to 130 goes in the next group, and so on. So she's put them in 10 centimeter intervals, and whether you're 101 centimeters or 109 centimeters, you still go in that same group. One other thing I want you to notice is you may have seen or noticed that we've got a square bracket on one end of this interval and a round bracket on the other end. So here's the square bracket, here's the round bracket. That means something. The square bracket means include the number beside it, and the round bracket means don't include the number beside it. Why would we need to do this? Well, the reason is so we don't have overlap, right? What if someone is exactly 110 centimeters? Well, then we want to know, should we put them in the first group from 100 to 110, or should we put them in the second group from 110 to 120? So with that in mind, the square bracket means include. So if someone is exactly 110 centimeters tall, then they would go into the 110 to 120 because the square bracket's beside the 110 in that case. That way, even if someone goes up to 109.99999 centimeters, not that we can measure it that accurately, but in theory it's possible to be just under 110 centimeters. Anybody up to but not including 110 would go in the first group, but exactly at 110 we roll over to the next group. So that's what the different brackets mean. And again, so when we've got these intervals, so then she did a tally. So every time someone who came in between 100 and 110 centimeters, she would put one little tick mark in the middle column. And then she just kept going until, how many people did we say it was? I don't think it did say. We'll find it out, though, when we'll be able to add it all up if we wish. So the first one, tally charts are easy to add up if we do them in groups of 5. So we got 5 here, we've got 8, we've got 16, 25, 35, 41, 34, 23, 14, 8, and 2. And then we could easily get the total if we wanted just to add up all the numbers in that column. So that's the first part. So that's one way of gathering data. I guess the last thing I'd say about that table is notice how the intervals, 100 to 110, 110 to 120, they're all equal size. It's important that they're all equal size. Otherwise, our table's going to look funny, and so will our graph. Now we can make up a quick graph for this called a histogram. A histogram is commonly used in statistics. It's like a bar graph, but with a couple specific special things about it. One of the things is that the bars are all run together, and that is to represent the fact that, as we saw above, all these groups the 110 to 120 and 120 to 130 and so on butt up against each other. So we don't leave space between the bars in histograms. Another thing about histograms is we generally just write the numbers on the edges along the bottom of the axis. So in our table, we start at 100 as our lowest height and 210 as our highest height. So we've just got to make sure that we have room to get all this on here. So again, I'll start at 100. Let me just really blow this up a bit. So 100 goes here, and 110 goes here. So I'm not putting it in the middle of where I'm going to do the bar. I'm putting it on the edges of the bars, again representing this idea that I'm going to be doing what's in between these numbers. So let's just write the numbers out, and then I'll demonstrate. And it just fits going up to 210. So that's the heights. To get our label on our axes. In single variable statistics, which is what this unit's about, that means that that's our categories. On the vertical axis, what we have is the frequency. Just how often do things fall into the different categories. Oh, and by the way, one other thing I'm going to put here on the horizontal axis, I'm going to put a little squiggle like this. That shows that I'm leaving out some numbers. I'm leaving out all the numbers between 0 and 100. So that's just a short form way to illustrate that. So we're just starting at 100. So now what I can do is I can make a bar between 100 and 110 that matches the frequency, which was 5, of the people who fell into that. So 5 people were between 100 and 110 centimeters tall. So I make a bar that high. And then the next one, if I recall, was 8. So between 110 and 120 on my horizontal axis, I'll make a bar that is 8 units tall, to the best of my ability. And the next one, I think, was 16 for the next group from 120 to 130. Okay, so here's the first 3 bars. And you can see that, again, 100 to 110 matches the first row of the table, 110 on to 120 on the graph matches the second row, and so on. So I can match them up. So the next ones were 25 and 30 and 25 and 35 and so on. So let me just fill the rest of this in. 25, 35, 41, 34, 23, 14, 8, and 2. So there's my graph. It sort of doesn't stand out very much, so since I've got the ability to color it in with my highlighter, I'm just going to do that so that we can see a bit better what this graph looks like. And again, this is called a histogram. Notice how it's made up of bars, but the bars are all touching each other, and they represent the number of the frequency of whatever's occurring between them. So it's not the best coloring job ever, but it illustrates the point. All right, so there's the histogram. Now you know what that is. Place a point at the top of the center of the top of each bar in your histogram. Join the points with a smooth curve. All right, I'll do this in red. So I'll start with this one, put a dot at the top of each one of these. And then I'll connect these dots with the best curve that I am able with my artistic abilities to be able to do. I sort of missed that one there, but anyway, close enough for our purposes. So it makes this mound shape. All right? Maybe you've been to see the Liberty Bell in Philadelphia or some other old-fashioned bells. if you use your imagination and squint a little bit, you might be able to see how it's kind of the same shape. That is why this type of graph is often called a bell curve. It's also called a normal curve. And the reason why it's called normal is a lot of things in the world can be represented by this type of distribution. So it is kind of normal. If you take everybody's height from a large group of people, most of them would be in the middle. You'd have a few shorter people, you'd have some really tall people, but most people would be in the middle. So that would be a fairly normal distribution for heights. Or you could do the same for weights, or many things that you could think of. So it's a bell curve because of the way it looks. It's a normal curve because of what it does. And this data approximates what's called a normal distribution. So again, it's normal in that it's pretty common. In a normal distribution, the data are distributed symmetrically about the mean. Symmetrically, all right? So it's pretty much the same on one side as the other. So the mean, the median, and the mode are close in value, and they're located in the center of the distribution. So even without having to calculate these, I could tell you that the mean, median, and mode, let's make it a little bit bigger. The mean, median, and mode are all going to be somewhere right about here in the middle. If it's perfectly symmetrical, then they will be exactly in the middle. But if it's slightly off, then that purple line I just drew might be slightly off as well. Definitely, we can see without doing any calculations that the mode is definitely between 150 and 160. It's the highest bar. It's got the highest frequency. But the mean and the median, there and there as well. Because that yellow area that I've colored underneath the graph represent the number of people who fall into each category, and they're equal numbers on either side, so they're going to balance each other out. So for a normal distribution, it's symmetrical. The mean, median, and mode are all located at the center. So that's one type of distribution, the normal distribution. Things don't have to be normal distributions, though. They could be different. One common different type of distribution is called a skewed distribution. And that's one that's kind of lopsided. It has the appearance of a normal distribution that's been pushed to one side of the mean. The result is an asymmetrical or lopsided distribution. Two kinds of skewed graphs. Well, it can be lopsided either way. It can either be right skewed or it can be left skewed. So in other words, it's just lopsided to the right or lopsided to the left. Think about which side is the tail on. So the right skewed graphs have the highest frequency on the left, and they decrease as you move right. So again, imagine it's got a tail. If we just sort of look ahead for a second at the next graph, it's got this general shape. I'm just looking a little farther down here, and we would call this the tail. The side the tail is on is what determines whether it's left skewed or right skewed. So in this case, the tail is on the left. That would be a left skewed graph that I'm looking at. So look for the side that the tail is on. So in this case, for right skewed, the tail is on right. And for a left skewed graph, the tail is on the left. For example, Sally picked up a handful of quarters. She recorded the year of each and made a graph. Is the graph normal, right skewed, or left skewed? So here is her. Again, she made a table up, although it's not. She made a frequency table, but she didn't put it inside an actual table. But you can see here on the left, we got the years from 55 to 60 and 60 to 65. Then we got the frequency for each one, and then it's been plotted as Well, it's been plotted as a bar graph. I got a couple problems with this particular graph. If it was a histogram, which it should have been, then she could have run the bars together, and this idea of going from 55.5 to 60.5 doesn't make a lot of sense to me. She could have just used the same idea as was used here with the square and round brackets. But we'll let that slide, and here's the shape of the graph, right? So you can see that it's got a tail on the left, and that makes it left skewed. Finally, we've got one called bimodal distributions. A bimodal distribution has two peaks. Bi, like bicycle, means two. Bicycle has two tires. A bimodal distribution has two modes. Remember, mode is the most frequently occurring of value. It's usually symmetrical, with frequencies clustering around two subgroups. For example, a class of grade 6 and grade 1 students each measured their heights. They recorded and graphed them. What type of distribution is this? Again, let's not worry about the fact that the histogram has been drawn wrong with spaces in between them, and they didn't use the square and round brackets like they should have. Just looking at the shape of the graph, you can see that there really are two modes. There's one mode at between about 110 and 115. And then we have this other mode that occurs about 155 to 160. You won't always see the individual bars, but what you will see is this definite shape that looks like this. So it's got there's two peaks on it, so two modes. And there you have it. So you need to just learn or get familiar with the different types of distributions, get an idea about how histograms work, and you should be good.